Hello, viewers, and welcome to Queen Amadi Smart Clinic. I'm your tutor, Sir Pius Paul Queen Amadi Sandi. In today's lesson, I want to look at functional matrices. So it's a functional matrices. Functional matrices. Somebody will want to know what's a functional matrix, right? Or what are functional matrices? A functional matrix is a matrix in which each element is expressed as a function of one or more variable, usually expressed in what? In X. That is, the elements are not only numbers, but they are what? Algebraic expressions, right? Let me just write it down so that you can get this definition. So we say a functional matrix is a matrix in which each element each element is expressed as a function of or more variables one or more variables, usually in X. So we say the elements are not what? Only numbers, but algebraic expressions. Algebraic expressions. Okay? So this is the definition. So we say a functional matrix is a matrix in which each element is expressed as a function of one or more variable, usually in X. We say the elements are not what? Only numbers, but what? Algebraic expressions. So let me give an example. Let me say the functional matrix AX is equals to, this is 2x, this is 3, this is x plus 4, and this is x minus 3. So now we can say that this AX is what? Is a functional matrix because the entries or the elements here are what? Are not only numbers. 3 is the only number we are seeing, right? All these ones are what? Algebraic expressions. You talk about 2x, x plus 4, and x minus what? 3. They are algebraic expressions. So we can now say this matrix AS is what? Is a functional matrix, and the variables are expressed in terms of what? X, right? The variables are expressed in terms of X. So AX is a functional matrix. AX is a functional matrix. So that is just it. So now we want to do operations on functional matrices, right? How do we add? How do we subtract? How do we multiply? We want to know that. So for us to be able to effectively carry on operations under functional matrices, you should know the basic and the normal operations under matrices, right? The process is the same. Now, what am I saying? Let's say you have matrix AX equals to 2x and 3, then you have x plus 4, then you have x minus 3, and you have matrix BX equals to x minus 3, you have x, then you have x plus minus 2, then you have x minus 6. Now, if we are asked to find ax plus bx, how do we do it? Let me just take out this part. So we are given to solve. Now we say this is matrix AX and this is matrix what? BX. We are asked to find AX plus what? BX. So you are just going to add the corresponding elements, right? In the first matrix and the second matrix. The operations are the same for addition, for subtraction, multiplication, the determinant, etc. So I'm going to, just do this one example. Then I look at its applications under differentiation and integration, right? So let's just say we are also asked to find ax minus bx. So if we want to solve this, we start with what? Ax, say plus bx is going to be matrix ax is what? We have 2x, then 3, then we have x plus 4, and we have x minus 3. We add it to matrix bx, which is x minus 3. We have x minus 2, and we have x minus 6. So now, the first element here, we add it to this, and the second element, we add it to this with this, and this with this. So how are we going to do it? So 2x plus x minus 3, right? We know 2x plus x is what? 3x minus 3. And you go again. X plus x is going to give you 2x. Then 4 minus 2 is going to give you 2 plus 2, right? Then you come again. 3 plus x is going to give you 3 plus x. Then you say x plus x, this is 2x. Then minus 3 minus 6 is going to give us minus 9. So this is the answer for what? Ax plus bx. So now let's go to ax minus bx. Ax minus bx. So this is going to be the order 2x, 3, x plus 4, and x minus 3 minus b, which is x minus 3, x minus 2, x, and x minus 6. Right? So how do we find this one? Just follow the normal operations on the matrices. So this one is going to, be like this. 2x minus x is what? Is x. Then you say minus 3. Okay, minus times minus now is plus. Then you come again. 3 minus x is the same as 3 minus x. So x minus x is 0, right? Then we say 4 minus times minus is plus. So 4 plus 2 is 6. This gives us 6. Then we come here again. X minus x is 0. Minus 3 minus times minus is plus. So minus 3 plus 6. It gives us what? Positive 3. So that is the answer for what? Ax minus bx. So in case you want to find a determinant, you follow the normal matrix determinant method. So now I want us to look at a question like this. Let's say given ax equal to sine x, x square plus 2 cos x, and x to the power 3 minus 4. So let's say we are asked to find dA dx and d square a, the second derivative, and this. So I'm going to solve this one, then I'll leave this one for you to solve as an assignment. then you drop your answer in the comment section. All right. So let me just take this part off. So how do we solve this one? We know matrix AX, we say it is what? Sine X, and this is X square plus 2, and this is cos X, and this is X cube minus 4. So how do we differentiate this functional matrix? You are going to differentiate each element inside this matrix to have the first derivative, right? So let's go. So this one is going to be dA dx is going to give us the derivative of sine x is going to be what? Cos x. The derivative of cos x is minus sine x. And the derivative of this expression here, x squared plus 2, is going to be x squared plus 2 is going to be what? 2x. And this constant becomes what? 0. So this is 2x. And the derivative of this one is going to be 3x to the power what? 2. So 3x to the power 2. And this constant 4 becomes what? 0. So this is the answer for what? dA dx. Thanks for watching. Make sure you like this video, subscribe to the channel, turn on the notifications so you never miss a video. Thanks for watching.